All right, so today we'll be simplifying rational expressions. Okay, so the page that you picked up when you came in, that is homework. Those are not notes. But if you'd like to take notes on the back of that, you are welcome to. Okay, we're going to start off with some easy ones. So, and I'm just going to jump right into examples because that is the best way to teach this type of lesson. So if we had 18x to the 6th over 27x to the 4th, what we kind of do in this case is we're reducing, or we can think about pulling out a common factor. I would like to think of it as reducing. So, do you see that we can rewrite 18 as 2 times 9? And then we could rewrite 27 as 3 times 9. So, what do these two have in common? 9. And they cancel. So, another way that you did this, probably 6th or 7th grade, is you would say, okay, what's a common factor for 18 and 27? 9. 9 goes into 18 2 times. 9 goes into 27 3. But do you see how you get the same thing? Both those mean the same thing. Okay? Now, this x to the 6th is the same as x to the 4th times x squared. And then we have an x to the 4th down here. So do you see that the x to the 4th cancel? Now, another way you can think of this is 4 of these cancel with 4 of those and leave 2. Now, this way, to me, is the easiest. This way shows what's happening, but you don't have to do it that way. This way is the easiest. So you look for a number that divides into everything, and then you look for any common variables and reduce them. So this simplifies to 2x squared over 3. Okay? Example 2. 3x squared over 12x. Okay, is there a number that divides into both 3 and 12? 3. Okay, so that's how I would do this. I would think 3 goes into both of these. So 3 goes into 3 how many times? 1 time. And then 3 goes into 12 how many times? 4 times. So now we've reduced the numbers. And then in the numerator, we have x squared, which really means x times x. And in the denominator, we only have a single x. So this one will cancel with one of those and leave how many? 1. So this simplifies to 1 times x, which is just x, over 4. Okay, we can have multiple variables. So let's say we had 16, a squared, b to the 3rd, c to the 4th, over 20, a to the 7th, b squared, c squared. All right, so what number divides into both 16 and into 20? 4. So we're going to say 4 goes into 16 how many times? 4. And 4 goes into 20. 5. And then we just start canceling. We have 2 a's in the numerator, but 7 in the denominator. So these 2 will cancel with 2 of those and leave how many? 5. These two cancel with two of those and leave how many? One. And two of these will cancel with two of those and leave two. And so this completely simplifies to 4 is left in the numerator, a b to the first, and a c squared. And in the denominator, we have a 5 and an a to the fifth. Okay, any questions about when we have a monomial over a monomial, a single term over a single term? Okay, so now we're going to do some where we have not just monomials, but also binomials and trinomials as part of our rational expressions. So this would be example 4. So let's say we had 2x plus 6 over 4x plus 12. Now, the major difference between this problem and all the ones that we just did is this has a different operation in it. All of these had straight multiplication in the numerator, only multiplication in the denominator, only multiplication in the numerator, only multiplication in the denominator, and over. There was no addition, there was no subtraction. So we could almost get slash happy. We can cancel whatever we want. It is all multiplication. But this one's different. This is not multiplication. This is addition. And you can only reduce when it's written as multiplication. Yeah. So, what we have to do is factor it so that we have it written as multiplication. So the numerator, do you see that the numerator has the greatest common factor? What is it? 2. And it leaves me x plus 3. Do you see that the denominator also has a common factor? What is it? 4. And what does it leave us with? X plus 3. Now, do you see that the numerator is written as a product? This term times this binomial. This times this binomial. Once we have it written as multiplication, then, and only then, can we cancel. You cannot cancel anything here. That is a mathematical no-no. Yeah, it's like touching a hot stove. It's bad. It'll burn. Okay? So we have to have it written as multiplication. Once we do, then we can cancel. Do you see that this numerator and denominator have a common factor of x plus 3? So this entire factor can cancel with that entire factor because they're identical. And now we're just left with 2 over 4. And what does that reduce to? 1/2. Okay, so we must always remember you can only reduce, you can only simplify a rational expression once it's written as a product. If it's just a sum, we can't do anything with it. Okay, so let's keep going. Right now, I can't reduce anything. Nothing will simplify as it's written. But if I can factor, then maybe it will simplify. Sometimes it does, Okay, a lot of times when I make up the problems, it does, because that's what we're trying to learn how to do. Okay, so do you see why last night's homework was important?
Yes.
How does the numerator factor? What does it factor to? 5 and 4, good. What can you multiply to get positive 20 that you can add to get positive 9? X plus 5 times x plus 4. Will the denominator factor? Yes. The denominator has a GCF. What is the greatest common factor of the denominator? 2. And when I factor out the 2, what am I left with? Okay. Now, the numerator is written as a product. The denominator is written as a product. Now, we can cancel. And in this case, they both have an x plus 4 in common. So we get x plus 5 over 2. Yeah.
Are they always going to have one that's the same? Like,
No. But I'm making up ones right now that do reduce and do simplify, so we can have practice with that. But if I just created any rational expression, it may or may not reduce. All right, let's try another one. 6x plus 24 over x squared plus 7x plus 12. Will the numerator factor? Yes. How does the numerator factor? Very good. Will the denominator factor? Yes. Okay. Now, they do have common factors, and they can cancel. So what we're left with is 6 over x plus 3. Can I say 3 goes into 3 one time, 3 goes into 6 twice? No. And I watched all of you write it. I should have stopped you. Why can't I?
because they're not.
Is it written as a product? No. No. And this is what we didn't know before this year, because I've seen it on a lot of work. This doesn't simplify anymore, because I can only simplify when it's written as a product. I can't turn that into a product. That is a sum. This 3 is attached to the x. And it can only simplify if there's an x plus 3 in the numerator. So this is it. We're done. Okay? All right. All right. Let's try this one. X squared minus 5x plus 6 over x squared plus 2x minus 15. And I want you to try this one on your own. We'll make this a you try.
What does the top vector do?
Could top factor into X -6 and then X plus 9?
Does that give you a positive 6 when you multiply them? Okay, now, when we're simplifying rational expressions, if the numerator or denominator is hard for you, start with the easier one. Because generally, if I'm asking you to simplify, something will simplify. So start with whichever is the easiest to you, and that'll kind of give you a hint at what you're looking for in the other one. So, if the denominator was easier for you, start there. If the numerator is easier, start there. Okay, so, in this one, once I have it written as a product, those two factors will cancel. And so this simplifies to x minus 2 over x plus 5. And we cannot cancel anything else. The x's cannot cancel because this is a difference. This is a sum. I don't have a product. You can only cancel if it's written as a product. Are we good? Okay. That is pretty much it for today. Now, I realize you have enough time to finish your practice problems. And that's okay, because it's a really busy time of the year. I know you guys are prepping for APs. I know you guys are prepping for milestones. I'm okay with you not taking work home. So please use the class time wisely and ask me any questions you might have.
Thank you.